All right, we are going to be talking about, what are we talking about today? Finding the sums of an infinite series. Okay? So, think about this. I've been teaching this for 19 years, and the first class I did this with, they're still finding the sum because it's to infinity. You go up to infinity, you guys are going to keep adding all the way up to infinity. So you guys will be working on this for the rest of your lives. You're welcome. Okay, here we go. Okay, find the sum of the infinite series. Impossible? How can you find the sum of infinity, right? How can you find the sum of infinity, right? Remember I said we're going to be doing this forever. You got to be adding forever because infinity goes on forever. You got to keep adding them up, right? Now, you can only do it if the geometric sequence is decreasing. In other words, the ratio has to be bigger than 0 but less than 1. So, for example, 1/2 or 1/3, right? Or 1/8. You can't do it if it's bigger than 1, like 2, because it keeps getting bigger. When it's like this, the ratio shows that each number is decreasing. So for example, if I have, this is Godzilla time. Actually, let me do it like this. Let's do a quick Godzilla time. You guys are writing that out, or you don't even need to write that out. But let's say I have a series that looks like this. Let's say I have n and then a sub n. Let's say my first term is 8. Let's say my second term is 4. Let's say my third term is, what would the next one be? 2. My fourth term is going to be 1. 1, right? And then my fifth term will be 1/2, right? My sixth term is going to be what? 1/4 multiplied by 4. 7 is 1/8. You see what's happening now? Eighth term is 1/16, and then ninth term is 1/32. See how it's getting smaller and smaller and smaller and smaller, which eventually it's going to be so small, it's going to be insignificant, and it's not going to matter. It's not going to change the value. It's only going to get to a certain point. It's never going to be 0, but it's going to be so small that it's going to have a stopping point at some point. A theoretical stopping point, not an actual stopping point.
Is that kind of like how atoms work? It's like technically atoms don't touch each other, but like that's your hand touching the paper, but technically you're not.
Whoa. You just blew my mind there.
Is that kind of like the same theory?
Maybe.
So like technically you're not, but you are.
I think I'm going to say yes. But I'm not an atoms guy. So, okay, here we go. Let's look at number 3 on your homework. Number 3 wants you to graph this, okay? Let's look at number 3. Graph the first 5 terms of the infinite series. Okay, so we want to graph this. So I'll give you a second to write this out. Number 3, to find the ratio, we want to go, I think you can visually see what the ratio is. Remember, the ratio is a sub 2 divided by a sub 1, which is 1/6 divided by 1/2, right? Which is 1/6 divided by 1/2, which is 1/6 times 2/1, which is 2/6, which is 1/3, right? I mean, you guys can see that it's 1/3, but does this fit my criteria as far as the infinite series? Is the ratio between 0 and 1? Yes. So we can find the infinite series. But that's not what this is asking here. We're asked to graph it. Okay, so S1. So my first sum is 1/2. So you're going to plot it at 1/2 right here, 0.5 into decimals. Then I want to go, right, now I'll do S1 plus S2, which I did on a calculator. I got that as 0.67, okay? We're going to graph that, right? Now I did it on a calculator as decimals because it might be easier, so I put that as decimals. 1/2 plus 1/6 is 0.67. I'm just adding them. I'm adding them as decimals. You guys can figure that out later. 1/2 plus 1/6 plus 1/18, basically 0.67 plus 1/18 is 0.725. We graph that there. But I'm going to keep going. Now, 0.745 is the next one. Should I pause so you guys can copy this down, I guess? I'll pause for a little bit. Pausing. I'll record it. Hang on a second. Louise. You can see that it increases by such little, like 1/54 is so small, it's only 0.745. And then you add 1/67, it's only 2/100ths of a decimal that it increases. And then eventually it's going to flatten out and it will not exceed 0.78. It'll keep going, but it won't exceed that because the increase is so small. So we got to figure out, how do we figure out that number, right? Without adding them up. How do we figure out the maximum of what it's going to be? How do you know if the series is infinite? It's if n equals infinity, right? What do you mean by that, Sensei? Well, you guys remember the n is on the top. So when this equals infinity, then guess what? It's an infinite series. And then that's what we got to do. Now, here's the formula for the infinite series. This is all you have to do. The sum of an infinite series is equal to a sub 1 over 1 minus r. This is actually way easier than this one that we did here, where we find the sum of the geometric series. The sum of the infinite series is way, way easier. So it seems hard, but it's actually, well, in my opinion, maybe you'll think it's hard, but I don't think it'll be that big of a deal. So here we go. Okay, now find the sum of the infinite series if it exists. Okay, so here is our series. It has to be geometric too, by the way. Now, can we solve for this infinite series? Like, does the sum exist? Meaning, does it have a stopping point? Look at my r. Is it between 0 and 1?
Yeah.
Yes. So it's 1/5. Okay, so the infinite series does exist because we are between 0 and 1. And so we're going to use this. The sum is a sub 1 over 1 minus r. So let's go ahead and solve it. So here we go. Here, and here. The sum of the infinite series equals a sub 1 over 1 minus r. Okay? You guys go ahead and try to figure it out. See if you can solve it. Okay, you guys try to solve that. All right, so here we go. Here's how you solve it. So a sub 1 is 8 over 1 minus, my r is 1/5. Now, I can change this 1 into, hang on, where's my page extender? I can change this to 8 over 5 over 5 minus 1 over 5, right? Because, right, that's, you have a common denominator, so 1's going to be 5 over 5, pretty easy. 5 take away 1 is 8 over 4 over 5, right? And then I'm going to write it over here. Is 8 divided by 4 over 5, which is equal to 8 times 5 over 4, right? Then there are a couple ways you can do it. You can straight up multiply. 8 times 5 is 40. 1 times 4 is 4. 40 divided by 4 is 10. or you can cross reduce, right? This becomes 2. 2 times 5 is 10. But anyway, it's 10. All right. Let's see here. All right. Find the sum of the infinite series if it exists. You guys go for that. So you got to figure out, well, hey, what's the first term? 3. You got to figure out what is the ratio, right? What is the ratio? What's the ratio? And then you just plug it in. All right. The answer is 18. So let's first figure out it's a flat out 18. It's 18 even Steven. If you do it on a calculator, it might throw you off. Don't do it on a calculator. So what's my ratio? A sub 2 divided by a sub 1, which is 5 halves divided by 3, which is 5 halves divided by 3 over 1, which is 5 halves times 1/3, which is 5 over 6. And you can see it, right? 5 times 5 is 25. 2 times 6 is 12, right? It's less than 1 and bigger than 0. Okay? So, starting value is 3. So let me get this out here. We have sum of the infinite series is a sub 1 divided by 1 minus r, where a sub 1 is 3 and r is 5, 6, right? I just did that for my memory. Is my memory okay? Did I get all that right? A sub 1, 3 over 1 minus 5, 6. Do not use a calculator here. Just go like this. 3 over, what's 1? 6 over 6 minus 5 over 6. What's 6 take away 5? 3 over 1, 6. Right? Which is 3 divided by 1, 6, which is 3 times 6 over 1, which is 3 times 6, which is 18. 18. Okay, look up here. This is asking us to write the repeating decimal, right? This means 0.222222222 forever, right? Usually put a bar over it as a fraction in simplest form. But this is a series. Do you guys know that? Guess what? This can be written as, hey, look, it's 0.2 plus 0.02, right? Plus 0.002 plus what? 0.0002 and so forth. Do you guys see that as a repeating decimal? So here's the $1 million question. I got 2 of them. If you get them right, you get $2 million. The first $1 million question is, what is a sub 1? $1 million. Mariah, very good. I'll get it to you later. I'm not sure when, but 0.2. The other $1 million question, so we got a sub 1 is 0.2. The other $1 million question is, what is the ratio? How do you find the ratio? A sub 2 divided by a sub 1. 0.02 divided by 0.2. What do you get? What? Julian, $1 million. 0. Is it 0.1 or 0.1, right? 0.01 or 0.1? I think 0.1. I think Julian's wrong. $1 million back. Sorry. 0.1?
Yeah, 0.1.
0.1. Oh no, double check. Punch in the calculator. Huh?
I said
110. Do I owe you $1 million? Mariah, I'm not sure if Mariah gets $2 million. Or Louise. Louise, you're gonna make $1 million on your own. I know it by the time you're 18. No, you're not. So, homies, let's say sum of the infinite series is a sub 1 over 1 minus r, where, I'll get out of the way, my a sub 1, if I remember correctly, was 0.2, and my r was 0.1, right? So go ahead, plug it in, and then we'll write it as a fraction. Okay, so, hey, stop talking, please. I can't hear myself think, even though you guys have already got this. Danny, da-da! Do you know what that means? It means I love you. Now listen. A sub 1 is 0.2 over 1 minus 0.1. We can subtract that using a calculator, or you could just say, hey, 1.0 minus 0.1, 10, borrow 9. Which is 0.2 divided by 0.9. And then you could just get rid of the decimals by moving them over to the right, and it's 2/9. Now, on your calculator, like I said before, you can punch in 2 divided by 9, and you should get 0.222222, right? You can check your answer on the test. Yes, you're going to have something like this on the test, which is on tomorrow. And 2 nights. Are there any questions on that? Sum of an infinite series. There's your homework, Isaiah. Even though it's not there. Page 387, 3 through 21. Odd.